is chemical vapor deposition. Okay, so this is somehow like the physical vapor deposition that we have already seen, but here we are getting the nanoparticle by the chemical reaction. So that is, this is the chemical vapor deposition. Okay, I'll try to explain the process with the help of this simple diagram is given here, how this process takes place to convert the vapors into nanoparticles. Okay, so here in the diagram we are having a reaction chamber, guys. This is a reaction chamber and we are providing a very high temperature to this reaction chamber. Okay, so that means the reactions are taking place at very high temperature, so that temperature and pressure is maintained of this reaction chamber. Okay, now we are having inductive or resistive heating we are providing to the precursor. So as I told you, precursor क्या होता है? Precursor is the thing with which we are starting the reaction. Okay, or we can say the precursor molecules, atoms, we are converting to the nanoscale. We are bringing the precursor molecule to the nanoscale. So precursor is that थिंग जिसका कि हमें नैनो पार्टिकल या नैनो मटेरियल को में कन्वर्ट करना है. ओके, सो दिस प्रीकर्सर इज कैप्ड ऑन द इंडक्टिव और रेजिस्टिव हीटिंग वी आर प्रोवाइडिंग. सो डेफिनेटली व्हेन द हीटिंग इज प्रोवाइडेड टू दिस प्रीकर्सर, द एटम्स एंड मॉलिक्यूल दे विल बी वेपोराइज्ड. सो दिस इज द vaporization is taking place with the help of this resistive heating. Now we are taking the help of a carrier gas here, guys. So with the help of this carrier gas will help these vapors to provide the direction to flow inside the chamber, inside the reaction chamber. So carrier gas का क्या रोल है? वो एक ऐसा गैस होना चाहिए definitely which cannot react, which cannot interact, which cannot react with these vapors. So normally carrier gas we used to use like your inert gases. Okay guys, so जो inert gases होते हैं they do not react, उनका reactivity नहीं होता है, so they do not react with other chemical materials. So carrier gas will choose such gases which are inert gases. Okay, cannot react with these vapors. उनका सिर्फ काम क्या है? They are just carrying these vapors, they are just flowing, helping these vapors to flow inside the chamber. So carrier gas are helping these vapors to come to this chamber. Clear this much? Inside this chamber, this is the chemical chamber, this is the chamber where the reaction will take place, or reaction chamber we can say, maintained at a very high temperature and a particular pressure is there. Okay, inside this chamber we have a substrate. Okay guys, so substrate is nothing but you can say, understand it like a material, एक material का platform है, and this material, your vapor, precursor vapor will react with that substrate material. Okay, so this vapor of precursor, they are going to go on that substrate material, उसके ऊपर जाके वो sit होने वाले हैं. These vapors will sit on this that substrate material, and now they will react, the reaction will take place on that substrate material of this precursor vapor. Okay, at high temperature and pressure they will sit on that substrate, and here reaction will take place on the substrate itself. Clear guys? By the reaction we will be getting the nanoparticle, by the reaction we will be getting our product. Okay, and in the course of this reaction, if some byproducts are emitted, because if the reaction is taking place between the vapors and the substrate material, there may be some possibility of byproducts. So those byproducts, there's a opening is there, those byproducts, other reactants, they can be sent out from this outlet. Clear guys? जो भी byproducts यहाँ पर create हो रहे हैं, they will be sent out. How? This carrier gas is continuously flowing. So the byproducts which are created here in the form of gaseous atoms, those byproducts will be sent out with the help of this carrier gas. So basically carrier gas is working into two ways. It is allowing the vapors, precursor vapors, to flow to the chamber, reaction chamber. And second work is what? It is sending the other reactant, sending the remaining the byproducts of this reaction with the substrate material outside this chamber. तो वो फ्लो कर रही है, उसको हेल्प कर रही है उस चैम्बर से बाहर जाने के लिए. क्लियर दिस मच गाइस? एवरीवन?
Yes, ma'am.
Okay, so there will be the reaction will take place on that substrate of these vapors, precursor vapor. As a result of the reaction at that high temperature and pressure, substrate पर ही वो reaction create होता है, and the product of the reaction will get on the substrate itself in the form of cluster. Okay, now this cluster we are getting the form in the form of vapor cluster. So vaporized form mein hai wo, so we need to condense them. Okay, so with the process, by the process of condensation, those vapors will be converted into material, into the solid form, and then with the help of the scraper we will scrap those nanoparticles. We'll collect those nanoparticles from the substrate itself. Am I clear, guys, about the process?
Yes, ma'am.
Any
Yes,
confusion?
ma'am.
Okay, fine. So uh, can go through about the process. In short, we can understand it like this. मैंने एक diagram लिया हुआ है. So here we are allowing the precursor gases. That means we have converted them into the vapors. Here, this is our substrate. This is our substrate material. This blue one you can see. This is our substrate material that is maintained at very high temperature. This is the surface of the substrate. Okay. Now precursor gases, with the help of that, those carrier gases are flowing inside the chamber. Okay, and they are sitting, these precursor vapors are sitting on the substrate, and as a result of the reaction with the substrate, they are now being converted into a different form. ठीक है, after the reaction the product I am getting here on the substrate itself, ये अब अलग color से थोड़ा show किया है so that you can understand these are the final product. Okay, the reaction between the vapors and the substrate will give you the final product in the form of nanoparticles. So ये final product is formed on the surface of the substrate that we need to condense and we need to scrap it from the substrate self, substrate material. That's it. तो ये हमने scrap करके इसको बाहर निकाल लिया है. And the undesired gas is continuously flowing, that carrier gas is continuously flowing through the chamber. The undesired gases will be expelled out from the chamber itself. So very simple diagram. By this very simple diagram, I have shown you the entire technique, the process, how the nanoparticles are. This time we are creating the nanoparticle by the chemical vapor reaction, like that way. I hope this is clear to you guys.
Yes, ma'am.
Okay, this is
Yes,
a
ma'am.
little bit different from the physical vaporization process. वहां पर कोई reaction नहीं हो रहा था. What we were doing, simply we were striking the electrons here. If you remember, this one I'm talking about, we were just striking this electrical, this is physical vapor deposition. So यहाँ पर this was our precursor target material, and we were bombarding electrons on that. By the bombardment of electrons, those atoms were converting into vapors, and that we were collecting on the substrate. So there was no chemical reaction. This was physical vapor deposition. On the other hand, in this process we are getting the final product by the reaction of substrate with that vapor, and that is being converted into nanoparticles. That's it. There's a chemical reaction. That's it. That is the only difference.